Cities are growing, mostly upwards, to the left, to the right. They are becoming more and more crowded, and the more people are in one place, the more important safety becomes.
Wenn ich in Hotels gehe, schaue ich mir als erstes die Brandschutztüren dort an und wie sie eingebaut sind und ob sie mit einem Keil hinterlegt sind oder unterlegt sind und ständig offen stehen. Das hat auch mit Sicherheit zu tun. Mein Name ist Andreas Kruse, ich bin der Standortleiter der Prüfstelle für Brandschutz.
Brandschutz ist so wichtig, weil Menschen dadurch geschützt werden. Wenn irgendwo ein Brand ausbricht, zum Beispiel in öffentlichen Gebäuden, gibt es Notausgänge und wenn man den Notausgängen folgt, kommt man immer durch irgendwelche Brandschutztüren durch und wenn die Brandschutztüren schließen, dann bleibt der Brand hinter der Tür und die Menschen sind dann eben sicher und haben Zeit, aus dem Gebäude zu entkommen. Mein Name ist Michaela Hanisch, ich bin bei JANSEN für den Bereich Marketing zuständig und da speziell für Stahlsysteme.
Wir befinden uns hier in der DMT-Prüfstelle für Brandschutz in Laten und wir führen hier heute eine Brandprüfung an einem Bauelement der JANSEN AG durch.
Bei einer Brandschutzprüfung wird immer das Gesamtelement getestet, es wird das System getestet, das Glas getestet und ich sag mal die ganze Schließfunktion, die dazugehört. Dann wird im Verlauf der Prüfung immer wieder geguckt, wo Schwachstellen sein könnten, ob Hitze durchkommt, ob Feuer durchschlägt. Wenn JANSEN Elemente testet, dann schauen wir immer, dass wir mehr testen, als tatsächlich gefordert ist.
Die Prüfung ist erfolgreich durchgeführt. 36, ich glaube 37 Minuten war die Dauer der Prüfung.
Ich fand die Prüfung super spannend und auch tatsächlich nachher mal davor zu stehen und mit der Hand hinzufassen und zu sehen, es kommt keine Hitze durch, das war sehr beeindruckend. Das Thema Sicherheit wird bei JANSEN auch zukünftig von hoher Bedeutung sein. JANSEN vereint in den Elementen Form, Design und Sicherheit. Und in Notsituationen ist es dann eben auch die Verlässlichkeit, die man mit diesen Elementen hat.
Ich bin auch stolz darauf, dass wir diese Tests hier durchführen, weil sie einfach ein Stück zur Sicherheit beitragen.
Ich bin stolz darauf, mit JANSEN-Produkten die Welt ein ganzes Stück sicherer machen zu können.
Good morning, everybody. It's great to be with you this morning. And on behalf of M2G Industry, we'd like to, and VETROTECH and JANSEN, we'd like to welcome you to this session where we'll be talking about new products to South Africa. So the insulated glass steel doors are not currently being used in the country. So we partnered and reached out. Actually, there's always a network to get here. And the network started a few years ago with a chap by the name of Pierre Boudin from Saint-Gobain, who introduced me to Paul Godot. And Paul Godot, in turn, introduced me to Pedro Rios, to Louis Cantero. And then, funny enough, we then got introduced to the South African Saint-Gobain representative, which was Monique Buttle. So it's been a journey to get here, but we are looking forward in this action-packed hour to spend some time with you just talking about the framework of glazed fire doors. I think the reality of bringing a new product into the market is it takes some time to just get some understanding of the product and how it works. And the reason we're doing this is as architects and developers, you have some idea of how to specify these products so that we can help you. So just again, thanks to my JANSEN AG team, to Paul Salalikin and to Jerry, to Gerard Play. And with no further ado, I'm going to take you through a brief introduction before I hand over to our first speaker. So just the outline of the talk today. I'm David, representing JANSEN by M2G in South Africa, and I'm sitting in my showroom. You can see it behind me here in Woodstock, Cape Town. I'll be handing over to the first speaker, which is Kobus Strydom. Those of you that know him have been doing testing at the Fire Lab Pretoria probably. So he's joining us online as the first speaker to give a framework, the regulatory framework for these systems. And then we'll be handing over to Andreas Makarvic from Switzerland, from JANSEN AG, and he'll be introducing us to the steel systems from JANSEN, so we have a better understanding how these systems work together. The steel works with the glass, and hence our partnership with VETROTECH by Saint-Gobain, and Louis Cantero will be joining us from Madrid in Spain to tell us a little bit about the insulated glaze products that VETROTECH offers. And then at the end, we're going to be joined by Stefan Vetter, who was the project architect on the exhibition hall in Dornbirn, a beautiful project which you will see a bit later on. So just to, before I hand over to Kobus, just to define what the reason why we're doing this. So as architects, we've had a number of calls from you and from developers saying, hey guys, I need a double door, it needs to be a Class B, and I can't find it in the country. And that's what we are trying to provide to you in the local market going forward. And we're doing that in partnership with VETROTECH. So where would you use these? So typically in areas where you would need fire curtains, there's places where, because of bulkhead details, it just doesn't make sense to use a fire curtain, or there might be some other maybe budgetary requirements to use fire curtains in all areas. Might not be the right way to resolve the issue. Another typical situation is where you have to do drenching with sprinklers. This is actually a building I'm sitting in at the moment, and that's a glazed meeting room. And you'll see a lot of sprinkler pipes to drench that. And in some countries, this is no longer allowed because the cold water on the glass under fire load can cause it to shatter. So this is a typical instance where you might want to use glazed, insulated glazing. This is the Class B typical doors that I mentioned at the beginning, and the small portal as per the code. And again, you might want in an atrium area to have an area where it needs to be more aesthetically appealing, and you would want an insulated glass double door, a Class B door. And then maybe the last one is, again, roller shutters with fusible links. And I know these are being used quite often now in lift lobby situations where you need both the shutter, the fusible link, and you need a motor, because some fire engineers are insisting that, you know, if it can't drop too fast, because that might be a life safety issue. So those are the typical situations that you would use it. And what I'd like to do now is hand over to Kobus Stredom, but just before that, I just want to introduce him. So Kobus, thanks to you and all the speakers for being here. I know that during COVID, it's been quite a stressful time for all of us. So we really appreciate you guys taking time out of your schedule to join us. So Kobus is Fire Lab's owner in Pretoria. He's been in this game for many years. You would never guess it looking at him. He looks still 23. But he's been with the, as you see on the screen, with the South African Emergency Services, and serves on various technical committees at the SABS. And you'll see he joined in 1977 and began his career in the fire safety design of building systems, and also the interpretation of the national building regulations. So he's specialized in the fire safety design of high-rise buildings and hospitals. And obviously with his work at the Fire Lab, he's seen most of the situations that require these products. So he's also done work in the industrial sector and the mining sector, including ballistics. And he took advantage of the privatization opportunity that arose out of the CSIR unbundling. And he then established Fire Lab. So Kobus, thank you. It's over to you.
Good morning, everyone. Thank you for the opportunity being here to share some information with you. I mean, one of the things I can say here is that glass is a very pleasing building element. I mean, it's not only what you see, but you can also see through it. So, but if it's not used correctly, then it can be a major disaster. So what we've got on the screen here, on the left-hand side, you can see during the progress of a fire screen being tested at us, and on the other side, just after the burners has been taken out, and you can see the deformation of the glass there. Now, I like to talk in pictures because that is normally the easiest way to define what is required. Now, if you look at a building, any building consists out of cells, and these cells are determined by means of occupation And you can have subdivision there as well with regard to tenants. And if you go double story, you've got just a multiplication of a number of cells which is going on top of each other. But you need to get access to an exit from all these cells. So therefore, it also creates corridors or passages. Now, if you look at the building, that all these elements containing there, it's got a specific function to do in terms of the building requirement meeting the regulation. So in that cell configuration of a building, if you picture that, you will have an external wall looking to the outside. You will have internal walls. The internal wall, between that, and then that links to a corridor, which is called an escape route. And then the escape route is maybe, if it's too long, it runs into emergency route. Now, in a vertical content, you also got emergency routes leading from top to bottom. So all these elements within a building has got specific requirements. So, as I said, single story, and that's defined by occupancy or tenancy. Now, the requirements in terms of the building regulations is quite clear. Firstly, you must allow for safe escape. Everybody knows that. That's a basic principle. But that's not the only one. So it also, any of these elements or cells within a building need to contain fire to the area of origin. Then there's a structural requirement as well. So unless structurally, it will not withstand the ravages of fire and it could break out. So structural stability is a requirement. Now, I know from a glass and from a glass point of view, we will never talk about glass. We'll talk about a glass system, because inherently the glass system need to have need to be a self-supporting structure to stand up. I know overseas structural issues is not with glass. It is normally the insulation and integrity that's relevant. And then another important aspect, prior to the big fire or moving in the building, you must have means and ways of controlling smoke. And then lastly, the requirement in terms of the regulation is you must provide safe access to the fire department to do the necessary rescue operations, and you must provide fire safety equipment. Now, those are the 5 basic principles that you need to address in any element that you use in a building. Now, compliance with the regulation in South Africa, there's 2 ways of doing it. Firstly, it is meeting the deemed to satisfy requirements, which is similar to many other countries like England. It's the approved documents that you need to comply with, or otherwise, in case it's not covered. Now, deemed to satisfy, you cannot provide guidance for each and every possibility. Therefore, you've got the second opportunity of rational design or engineering-based design. That is where you apply principles based on information, literature, test reports, whatever, to validate. And that is why our logo at the lab is innovation through confirmation. Now, the application of the regulations, glass will always be used in conjunction with one or more of the following elements. As we said earlier, you will have an external wall in the building. Now, that external wall could be glass, but it also needs to comply to certain requirements. Well, that's not going to go on. Okay, and then you have internal walls. Now, internal walls can be a division within an office or whatever, but it could also be a wall adjacent to an escape route. You've got a floor which is separating in multi-level situations. You've got a roof. For which in South Africa we don't have any requirements unless it's applied over a certain area. Then external walls, if we talk at that, you may have, depending the height of the building, you have elements within that to supplement your occupation or your divisional separating elements. A portion of that should comply to those requirements externally. Internal walls in offices, only 20-minute requirements. Internal walls between offices, it's not a requirement, but if you look between tenancies, you may require to have a 30-minute division there, and also adjacent to escape routes, a 30-minute requirement. That is on the basis that your escape route is within the deemed to satisfy requirements, not exceeding a maximum length. Then you've got tenancy separating walls, which you'll find in attached buildings, flats, hotels, dormitories, and whatever, where you have a 60-minute requirement. Occupancy separating walls, you've got 60, 90, and 120. And then division separating walls, which would be 60 and 120. Now, if we define an opening, you've got to look at the protection of opening. Now, any one of these walls cannot stand alone. You will either have glass facing outside, or you'll have a door going through a wall, or you have a wall or a window in a wall. That is why we've given all these fire resistance ratings. So that means if you use glass or a door in one of the openings there, it must have the same fire resistance. That's why I've given the picture. Now, on the external side, you've got another aspect there. It's radiation and safety distance. So if you use it externally, or you may even use it internally, but then you have to look at safety distances from a radiation point of view. And that is why if you use an insulating glass, that will give you the same function as a fire-resistant wall. So if you put it in there, or you can use that as a fire barrier, where it's you only need to worry about radiation, or not radiation, not a major issue. That is maybe separating within a building from an aesthetical point of view. You can use that as a fire barrier. And then lastly, you can use glass as a smoke control barrier within a building. And those are the basic things. So the important message that I want to bring over today is, if you visualize the building and all the relevant elements within a building, if you got an opening in there, and then you must consider what is the requirement that pertaining to that wall. And very often people ask and say, yeah, but why can't we use it as a fire door, for instance, if you're talking non-fire resistant glass? You must also bear in mind that in the evacuation of any building, if a fire incident happened, there is pandemonium. Now, if you look at the sociological aspects with regard to an emergency, there's only 12% of the total population or occupancy in that building which can act rational. So they can take the lead and they can move onwards. And then you've got the bulk of the people, which is approximately 75, 76%, which can act if there is a leader to provide that. But you've got 12% of the people that can't react. So therefore, it's very important that where you use glass, especially if it comes to emergency routes, whether you are allowed to use visibility or not allowed to use visibility. Because if people had to move and make use of an escape route and they see flames, they will not use that route. And then you can have a stampede on a stairway, whatever. And the other thing also is that from a fire point of view, fire safety point of view, giving safe access to fire department people, they come into the building, they use the emergency routes going up. So visibility is very important to them, to have a look at a specific floor, what is going on. Very often people ask, why can't I use a larger glass panel in a door? Because that visibility in a fire door is normally there for the fire department to see what's going on. So you can have a glass panel. It's not depending on the properties of the glass, but that is a functional thing to give visibility to a floor and know what's going on. Now, it should be remembered that you can use a fire-resistant glass and you can create the same properties as for a fire door, but then it will not allow any visibility on that floor. It will do the job and it's 100%. So those are the considerations that you need to look at. But otherwise, glass is very flexible and it gives nice and aesthetic things. But if it's not used correctly, then it will create a problem. Just coming back to one of the aspects that I've mentioned, that fire resistance on external walls. I normally ask people, if I do a presentation, I ask, what is the difference between an external wall and an internal fire division? The answer is exactly the same. Whatever is happening there, the external wall must also have the ability to prevent not only lateral fire spread, but also vertical fire spread. And that is why when you come to occupancy and division and tendency separating elements, you'll have an external component of a wall, which also have fire resistance. Now, if you come to facade wall construction, those aspects need to be taken into consideration, and you can combine glass with it. Now, we normally say that it's very simple. If you do an external facade, then you can use your structural elements on the inside of the building edge and your glass facade and your aesthetic part of the building on the outside. But if you use a construction which is completely outside, then it's a very complex design which you must take care of to make 100% sure that you meet the requirements. Because moving outside the building edge, you will have a primary structural frame to take care of the structural components, and then you'll have your secondary frame responsible for your visibility and insulation, whatever is required. But being outside, you must also be concerned about the necessary requirements for fire protection. Of the brackets, you'll have fire seals and smoke barriers, which also need to be incorporated. But from a fire safety point of view, glass can be used very safely, but then it must be used correctly. Thank you so much. If there's anything, the presentation will be available, and I think it can be accommodated if there's any questions at a later stage.
Thank you, Kobus. It was very informative. And just for the sake of time, we're gonna keep moving. So I'm just going to introduce the next speaker. And and again, Kobus and the rest of the speakers, thanks again for those of you who are listening. All our speakers are not speaking in their mother tongue, so thanks for speaking in English. I'm handing over now to Andreas Makarovich, who is training manager at JANSEN AG in Oberried in Switzerland. And he's responsible for the knowledge transfer and the development of the international market. So he's been instrumental in helping us develop both our local staff and also our metal workers across the country. Currently, Joburg, Durban, Port Elizabeth, and Cape Town. So thanks for that, Andreas. And prior to joining Janssen, Andreas worked in the field of product development for Hilti, Geberit, and other companies in the country, and also holds degrees from Thunderbird University and the University of Arizona. And he's going to now give delegates an overview of the steel systems, insulated, not insulated, and some of the advantages of steel over aluminium. Thanks, Andreas.
Thank you, David. Let me share my screen with you. Okay, thank you. Thanks, David, for the introduction. Andreas Makarovich, my name. I always say my job at the Janssen is really to share the passion and the enthusiasm we have for steel. And I'll try to do this today, and I have 15 minutes for that. So let me just show you what I have lined up here. I will talk about Janssen systems. I will introduce you to the whole portfolio of Janssen. This will include the non-insulated systems. I will continue with the thermally insulated systems, which actually represent the bulk of sales here at Janssen. I will continue with facades and roof glazing. This is the FIS transom and mullion system. I will continue with fire systems. This will be actually let's say the center point of my presentation. And I will close my presentation with giving you a couple of reasons why steel is the ideal material when it comes to doors, windows, and facades. Let me begin with the non-insulated systems. These systems, when you look through the Janssen catalogs, are called economy 50 and 60, depending on the width, the face width of the profiles. We have 50 millimeters or 60 millimeters, Art 15, and Art systems. All these four systems are based on the same principle. We have a cold-rolled induction welded profiles. They are designed, all these systems are designed for indoor applications. We can produce doors, windows, of course, fixed glazings to separate compartments within the building. In moderate geographical areas, we also see the use of these systems for the outside applications, entrance doors, and even building envelopes. You can also make fire doors made out of these systems. Fire doors in the class of non-insulated fire stop, classes E and EW. So we will stop the fire and the smoke from passing from one fire compartment to the next, but the thermal radiation will not be stopped. It will pass through the frame. So only non-insulated systems. Maybe these systems will not have the best thermal values. This is why they're used for the indoor applications, but they do offer the design freedom and the statical strength of steel. Therefore, they can also be used for folding doors, sliding doors, larger elements, and safety systems. When I say safety systems, I mean burglar resistance systems, bullet resistance, burglar resistance up to the class RC4, which is quite high in the market, bullet resistance up to the class FB6, which is a machine gun, a Kalashnikov. On some projects, we have also realized solutions which are explosion proof. So these systems will go a long way. A couple of examples, inside applications, sliding door, and a folding door in a private house. Let me move to thermally insulated systems. Here we talk about the JANSEN system, JANSEN HI, highly insulated, and the two ARTE systems, small, thin profiles, ARTE 2.0 and ARTE 66. These systems are based again on the same principle. We have two half shells, two steel half shells connected with an FRP insulator, FRP fiber glass reinforced plastic. The chambers within the profiles are separated by aluminum screens, giving or increasing the thermal values well beyond the passive house standards. We can make doors, windows out of these systems, folding doors as well, sliding doors, and safety systems. Safety systems, of course, here again, I mean burglar resistance, bullet resistance, finger protection, and also emergency panic doors. All our safety systems can be equipped with the panic functions, panic function B, C, D, E, depending on the requirements. A couple of examples here. This is a residential building in Amsterdam, ARTE 2.0. Let me move on to the thermally insulated fire systems. Here, JANSEN features two profile families. The first one is JANSEN 2. The system or the principle actually is the same as the insulated systems. We have two steel half shells connected with an FRP insulator. Additionally, these systems are equipped with cooling material, cooling agents. In the case of JANSEN 2, this is plaster, gypsum, two inserts on both sides of the profile. The role of the material is to cool the frame, to cool the profile during a case of fire, thus allowing us to cover the classes EI. So these are thermally insulated fire stop systems up to the duration of 30 minutes. We can make fire doors out of JANSEN 2 and also equip these elements with safety features. Again, RC, burglar resistance, FB, bulletproof, panic functions, finger protection, and so on. Let me move to the next system, which is JANSEN C4. So next to JANSEN 2, JANSEN offers a, let's say, state-of-the-art system for fire protection, insulated fire protection. Again, the same principle, two half shells connected with an FRP insulator. In the case of JANSEN C4, C, by the way, stands for ceramic mass, fourth generation of the ceramic mass, which fills the profile. The profiles, as you see on the picture, are fully filled with the ceramic mass. The profiles feature a plastic conduit for electrical cables or an additional locking point, the locking rod that was run through the conduit. So prepared for several different functions. The ceramic mass will have the same role as the gypsum inserts on JANSEN 2. They will cool the element, they will cool the frame, and in connection with an insulated glass, we can cover here classes EI 60 minutes, EI 90 minutes, and on projects we have realized also values of 120 minutes, 2 hours. The combination, so let's see what elements we can make. Of course, fire doors, separations, fixed glazing based on the system, and equip these elements also with safety features. Again, here we speak about bulletproofing, burglary resistance, finger protection, panic doors, emergency exits. In fact, JANSEN 2 and JANSEN 4 are often used to produce multifunction doors that feature all these functions in one. The JANSEN C4 doors, emergency doors, are the doors you will find, or the systems you will find across Europe in shopping centers, cinemas, and other public spaces. Let me move on to the facade systems and roof glazing systems. And within the JANSEN portfolio, you will find them under the name of FIS. FIS stands for Fully Insulated Sprossensystem. In German, that means mullion and transom system. FIS can also be built as a FIS basic system using the carrying construction not based on JANSEN profiles. So here the design freedom is great. You can use either the full package from JANSEN or base it on your own carrying profiles. FIS Fire features the fireproof version of the system, classes 30, 60, and 90 minutes. Facades can be made out of FIS, roof glazing, fire solutions. So as I said, all these systems, either the standard version or fireproof version. What you see on the right side of the picture of my slide is a acoustical highway tunnel in Poland, in Warsaw. This is the FIS system actually used as a slightly different application. The tunnel is 1.4 kilometers long, and this is actually the largest, volume-wise, the largest FIS project we have realized in Eastern Europe. Safety systems, as I said, also can be combined with FIS. So here again, we have the option of equipping a facade or a roof glazing with the bulletproof functions or burglar resistance functions. Now the question, why steel? Why do I mention steel so many times? Steel is really the great material for windows, doors, and facades. And let me tell you a couple of reasons why this is so. Fire resistance and thermal expansion and thermal conductivity are key when it comes to fire protection. Steel has a higher melting temperature than aluminum, 1,550 degrees Celsius versus 660 degrees Celsius, and this shows. This shows not only in the fire stop tests. Here you see on the left-hand side an aluminum handle on an aluminum door system, which melted after 10 minutes of the test duration. In the middle, you see the expansion or the thermal expansion of a double leaf door during a fire test. Steel expands less, has a less or a lower thermal expansion coefficient than aluminum, actually half of it. Steel will stay tight, will stay in place. Thermal expansion is also key when it comes to large elements. Imagine a facade 130 meters long and 20 meters high. The expansion will be enormous here. And again, it makes sense to use steel on such projects instead of aluminum. Thermal conductivity is also something that I would like to mention at this point. Steel is a better insulator than aluminum, and therefore it has better values, better thermal values when it comes to thermal separation. The next reason why steel is the best material for windows, doors, and facades is its statical strength, weight, and dimensions you can reach using steel. The statical strength is way higher than aluminum. It's actually 3 times higher than aluminum, which leads to the possibility of building slimmer, building taller and wider. You can get much bigger surfaces of glass or built within the steel frames than on aluminum. The looks of a steel connection and let's say the stability of the connection is also greater on the steel frame. We weld steel frames, steel profiles, and not just plug them in like you see on the right-hand side on the aluminum construction. So all in all, more glass, less visible profiles. And the last reason I would like to mention today is the design freedom and longevity of the material. With steel, you can, well, I could actually say the steel is really the material that makes architects' dreams come true. You can see it here on this picture. On the left-hand side, we have our a Canadian partner architect who installed a Arte 2.0 door, pivoting door in his house, in a nice house on the lake. And you can actually easily understand why he did that, to enjoy the view. This would not be possible with any other material. On the right-hand side, you see a concert hall in Norway. This is Kilden, one of the biggest facades realized with the FIS system, 120 meters long. It is a curved facade. At the highest point, it surpasses 20 meters. So one of the biggest projects based on FIS. Again, only steel can do things like that. Aluminum would be just no good for that. So all in all, to summarize my little presentation today, the systems we offer at Jansen allow the construction of any element that constitutes either a separation of an inner space in a building or build the outer skin, the envelope of a building. Steel is strong. It has a long longevity. It does not require any reinforcement when it comes to oversizes and large loads of glasses. By the way, the concert hall you see here was equipped with glass elements up to 1.2 tons of weight. This is what steel can carry. All in all, the best stuff. This is it. This is what I have prepared for today. Thanks for your attention, and I will pass on to the next speaker, or to you, David. Thank you.
Thank you, Andreas. That was very informative. And maybe just to clarify, one of the things you mentioned was the facade, and I'm glad you brought up the St. Kilden Art Center in Norway, because that's the typical situation that it's best suited for, where you have these concourse facades, tall spans, and you want slim mullions so it doesn't obstruct your vista. And you mentioned about the expansion or the coefficient of expansion, and typically in the unitized systems that's not a problem, but as you showed us there, the stick systems, that is a problem. So I want to just show you one more thing that Andreas mentioned. So this is familiar to all of you as architects, fire engineers, fire chiefs, and others. This is a SANS code. Now, Andreas mentioned EW and EI, and those of you familiar with European codes, that's E is for integrity, EW is for radiation, so reducing the thermal transmittance, and then EI is for insulation, which is kind of the key of our topic this morning. So at the moment in this country, like class F is the class F door at the bottom, 30 minutes stability, 30 minutes integrity, and then you'll see insulation not required. So currently we can do that with glass in South Africa, but as soon as you have insulation requirements like you see on the screen here, class A, class B, D and E, then you need insulated glass. And for that reason, we've got Luis Cantero, who's been in the space for a long time, joining us from Spain, from Madrid. He's the country manager for several South Europe and Africa countries, including South Africa, and has been in this industry for over 30 years, and specifically in the fire space with VETROTECH for 13. He holds a technical and MBA degree, and Louis will be giving us an overview of the glass options from VETROTECH, and maybe be a help to you as architects when you are specifying. Thanks, Louis.
Okay, thanks, David, for your presentation. It's a pleasure to be here with you, and thanks to all of the participants. I'll share my screen right now. I'm sorry if because English is not my mother tongue, but I hope all my colleagues will also help with the language if anything doesn't work. The goal of this presentation, 15-minute presentation, is that you understand all the capabilities of the glass, and to differentiate the three options that we have on glass. Is the integrity, as David said, and E, in English, EW, like heat radiation control, and the fully insulated fire resistant glass, but in Europe standard we call EI. Not sure if this presentation is working.
Just give it a chance, Louis. Sometimes it'll come suddenly, so maybe just use your arrow keys and see if your arrow keys work. There you go.
It's coming. It takes time. Yeah, I'm far. One of the goals is because sometimes we see that the prescription is not really correctly done on projects, and then the construction company becomes crazy on what to do. So one of the goals I have in this presentation is how to clarify, how to specify fire-resistant glass to meet with the South Africa or Europe standards, and to be, let's say, to know all the passive fire protection district terminology. Also, what is important for me is to combine the acoustic property of the fire-resistant glass, which is not always something that you take in consideration when you try to create your building. Acoustic is something which is an issue in Europe, and I guess it will become also for the other areas in the world in the coming times. At the end, the basic of designing fire-resistant certificates system for windows, partition, and friendly system applications are very important in the future. And nowadays, because most of you architects desire to have open spaces with a clear vision of the elements. VETROTECH, what it can help you is to do this prescription, combining all the elements we can have in glass, which is security, the acoustic, thermal, solid control, and the aesthetic. The glass can be as complete, as have many functions, many properties, many performances as you might. It's only a question of adding more performances to what you need. Of course, the most important when we talk about fire, it's fire resistant, it's controlling and the fire, the effects of fire, not only in life, in saving life, but also in protecting goods. And as Andreas said before, there's also the possibility to combine fire and bullet resistant explosion and things like that. This has been tested, and we have more than 40 years experience in producing this type of glasses. Of course, all of them are certified. All our solutions has passed and tests in an audited laboratory. All these fire solutions do have to achieve the local standards in South Africa, in this case, as we are talking. And I want to be more precise on this thing. As Kobus said before, there are several ways to guarantee that the solution it's okay with the local regulation. That means, well, either you have a test report, a test done, or you have an expert that can guarantee that the use of this specific solution is okay and it will work. So we need to be very cautious on what we are proposing to these buildings, because once it's installed, you forget about it until the fire comes. If the fire comes, then and then the solution is not working, then we have something which doesn't work and does not save lives. And at the end, I wanted to say these requirements, as I said, can be added to fire-rated glasses. Here is just a small slide to see the three configurations that we have with the glass, the three options. My colleagues have already talked. From the right side, you have the most basic one, which is the E, integrity, which you just create a physical barrier between the fire, the flames, and the smoke, and the people to protect, or the goods to protect. It's a wall. In this case, it's glass, but you cannot control the temperature. And we have to know that 90% of the cases, people die because of the temperature of the fire that comes into 1,000 degrees centigrade. On the other way, on left, you have the most performant glass classification, which is EI, which is insulation. There you can compartmentalize and block the heat transfer. So that means that, as you see in the pictogram, if you stay close to the glass, even when the fire is 1,000 degrees on the other side, you can be safe. And in between these two categories, there is an EW category in the European standard, that does not happen on the South African standard, which is EW. That means you have a partial heat control of the radiant heat. So it can be safe, but you cannot stay there for very long. Okay. Now I won't show you, because I'm quite late on time, all the video, but I just want to show you the consequences of having the heat in on the glass. I can go. You can see here on how it's just the consequences of having the effect of fire, the temperature of the fire on the other side, on the protective area.
A piece of cloth and paper are stuck on both the glass panes fitted into a frame. They simulate objects on the non-fire side during an event of fire. What do you think will happen to them?
Okay, I think that's enough to show you the difference between an E and EW or an EI. It's on one side, the temperature is not controlled, so you cannot consider that area safe. On the other side of the partition you install, and on the EW or the EI class, where you fully control the heating of the fire, then you create a safe area to be protected from fire. This slide here wants to show you how multifunctionality or how flexible the glass is in all the buildings we can show. It works for doors, single double doors, and you can see with partition or curtain walls, exterior glazing system, horizontal applications like here, like walkable floors up to 400 kilograms, smoke barrier systems, internal partitions, internal doors, and all those things, including also, if needed, something like design, like colored glass, like laminated glass for safety reason, anti-burglar, bullet resistant, all what we need. Even we can provide solution for stairs, walkable stairs in fire, also resistant to fire. Okay, so you can be as flexible as you want with your designs, and you can count on glass that satisfies the needs of a fire resistant, and also the local requirements instead of solar gains, isolation, thermal isolation, and so on. That is the way we normally treat the prescription with architect. The first question we place then is what is the fire resistant level you request? Do you need an integrity only, a heat radiation control, or fully insulated? And then what is the time of fire you need to evacuate your building according to the standards? It can go for 30 minutes to 120 minutes. And then, of course, what system do you need? Do you want to use steel, aluminum, or timber? Of course, steel, as Andrea said, is the one you will get the lowest thickness and the more sizes according to aluminum or timbers or other solution. So if you don't want to see a frame, you need to go with steel because it's the most suitable solution. Then we have to think about what application or use do we need. Is it an interior? Is it external? Do we need double glazing? Do we need solar control? And something which is very important for us, if it's fire origin, it's one side or two sides. We don't have to propose different solutions if the fire comes only from one side or if it comes from two sides. That is, as I said, very important. The system application, that can be a single window, a partition, a single door, a double door, an asymmetrical door, a facade, or an atrium, horizontal, slope, or inclinated application. Why this fifth point? Because all these solutions are tested, and they are tested under different standards, and they're tested differently. It's not the same to test a door that to test a partition. It's not the same to test a single door that a double door. So it is important to be aware what we have tested and what has been proposed for this for your building. We cannot certificate a double door with just a single door test report. Okay, and then at the end, the last point is just the configuration of the glass itself. Is it single glass because of interior application, or is not needed thermal or acoustic performances? Is it double glazed door? Is it laminated because you need to protect also from attack from external whatever people or whatever it is? Or do you need some opacity, some confidentiality? Do you need to control the noise? Then you have acoustic PVV, and we need to know also what is dB values, and if we are talking about RA or whatever. And of course, it's important to know wide by high, because we are limited because of the testing. This is the slide we normally send to the architects, so they will fulfill with all the elements they have, and if they don't have it, then we will help them to define what their requirements. This is just an example of the test. In every test we run, we have a test report at the end, and they give in this, if you see in the right page, the sizes, of what we can propose and the configuration. This is very important. We cannot go with one single window test to run a partition and to certificate a partition. That's why we have run together with JANSEN more than 4,000 test reports, which are available for all markets, and because of the different improvement we have done with them with the timing. This is just an example of all the performances we can have on our DOP, on our data sheets, including the light transmission, the performances, and everything. And the last slide I can give, the glass is a green product. We have all the EPD certificates. We have all the green levels, and we are working every day in reducing our impact on the economy. That's the end. Sorry if I've been 6 seconds late. Sorry, David, and I pass you again.
That was very informative. Thank you, Louis, because I think your tables and schedules will be very helpful for guys when they're trying to take a view on specifying these products. So thanks again for that, and your English was excellent.
Thanks.
All right, so our next speaker up has joined us, and we've got Stefan Vetter, who is joining us from Basel in Switzerland, regarding a case study in Dornbirn in Austria. It was actually with his previous practice, Marte Architects, and Stefan Marte was happy for Stefan Vetter to give us this case study. So he'll be joining us. He's done a lot of work in the space, and he actually had a portfolio online, which I can't show you, just to give you an idea of what he's done. But he's done projects across various project scales, from exhibition spaces and large buildings to smaller, more intricate, articulated residential developments. So I can't show, but Stefan, thank you so much for joining us. I'm going to stop sharing my screen, and then you can take over. Thank you, Stefan.
Hello, everybody. Hi, David. Thanks for the introduction. We continue with the perfect English from my side. No, I'm glad to show you some insights over our architectonical ideas on the buildings of the exhibition halls of Dornbirn. Currently, as I'm living and working in Basel, I am working at SSA Architekten. Before that, I was working with Miller Maranta also in Basel. And 5 years ago, I was happy to join the team of Marte Marte, and I worked there as a leader of the project during the construction from 2015 to 2017, almost about 2 years. And I will give you a whole overview of the situation, the building, the whole company, and of course a little infos about Vorarlberg, and then we dive into the building and we have a look at some special rooms and situations, and I will have some words with you about the design and architectonical ideas of it. So perhaps we take the next slide for further introductions. So here you see a little picture about the countryside of Vorarlberg. In the center there's the Messe Park, so there's not only 2 exhibition halls, but there are really a lot of exhibition halls, and they are circled in a little courtyard. And the Messe, you have to know that Messe is the company who runs the building, and in case of Dornbirn, there's also people from the government who share money in the Messe. So they also have to decide how is the quality of the building, and is it okay like this or like that, and whatsoever. And to Vorarlberg, there's important to know that Vorarlberg is really a small part of Austria, close to the border of Switzerland, and it's very known in our part of Europe because of its very good traditional like crafting skills and long history of very high quality wood constructions and architectural. There are a lot of famous architects also from it. So and it's like a small countryside with a lot of villages in it, but they have a very strong economy, so they are happy to have also those big exhibition halls for show off their products and productivity. So we can dive into the next slide, please. They have a little, I think, it's a black plan. In Germany you say Schwarzplan of the situation. You see that the black building, the long it contains 4 separate halls of exhibitions. There are 2 concrete halls, small ones with the entrances, and in between them you have a large scale wood construction. And about the design, we have to say that first of all, perhaps about the location, you see there's a big roundabout, and on the left hand side you have a white line, and this is the Autobahn, and on the right hand side you have a little you have a few houses. And it's the part of Dornbirn. Dornbirn is a little town with 40,000 inhabitants, and they have the huge Messe I think for the whole country they use it. It was necessary to get rid of 2 old halls because they weren't safe enough anymore, and they were too small, and they had the problem that in the old exhibition halls you were not able to make like huge conventions with crowds of peoples, and you have the situation that they had problems with loud concerts because very close there are neighbors. So the key was to build some new exhibition halls which fulfill every aspect of those teams. And for the design, it's to say that you see these elliptical shapes on the roof and in the facade. And these are like they are meant to mark the entrances of the building. And you can see on the right-hand side of the location, there's a huge elliptical shaped building there. There's a big tower. And yeah, I think they took the idea of the elliptical shapes, put it into this huge black box of exhibition halls. Okay, so let's move on. Here you see the outside of the building. Those big letters mark the great halls. It's the biggest one is the 11, and there's a smaller one, the 9. And in between, you see the red of the entrances. On the left-hand side, it's an entrance for humans and smaller pieces of work. And on the right-hand side, you have a really huge loading area where all those trucks can turn around and they even drive into the exhibition halls, of course. And here you also see the strong concept about the use of color. So they're not afraid to work a little bit radical. And in that case, the red comes also from the Messe company. They use a red in their logo. So Mate said we'll use the red also for the entrances and for some radical concept in the use of color. This is the outside view, and now the next page, I think it's the view from the courtyard of the Messehallen. Yes, thank you. There you can see it's the big entrance. It's in the Halle or the hall 10. It's in between 9 and 11, and it's a very important room because there you have the entrances to both halls and a huge foyer, which is also big enough to make some events. And you're lucky enough that through the big glass facade, you're able to watch through the foyer into the halls. So you have a little bit of impression if you're in the courtyard, what's happening in between or in the black holes. I think it's a very special room, and it's also there where we used those glazed insulated steel doors to manage those big openings in the building. I think we can move on to the ground floor, I guess. No, it's a little picture or big picture about our loading area. It's very, it's quite impressive. And it's really big enough for a truck to move and turn around in here. Thanks. I think we can move on. There's the ground floor. In the center, you see the huge loading area with a lot of doors to get the people outside if needed, and some huge doors to get the truck inside if needed. And in between the halls in the front, there you have the foyer with the big elliptical shape in front. And you see small on the left, on the right-hand side, a big glass part which allows a view through the foyer into the halls. On the right-hand side, there you have the little hall 12, and this hall on the right-hand side and the loading area, those are concrete buildings. The rest is wooden, and the facade is fully metal covered. So that's about it for the moment. Next, please. Here you have a view from the old halls into the new buildings, and you see the small hall of the hall 12. And later you have another view through, again, glass doors, and there you see you have an inside of the big exhibition hall 11. And in the back of the building, very small, you can already see the foyer. So it's really from the outside it's a black box, but inside you really have a great. There's a lot of points where you have visual communication in between the halls, and it's quite interesting. And also you can see the use of the colors again. So. Here you see a section through the halls. I think it's about 15 meter high and 75 meter in diameter. And yeah, in the top you have a huge wooden construction, which is I think 5 meters high. So to have a huge exhibition halls without any constructions in between the facades. And we had a lot of discussion because we wanted to paint everything black in the halls, and because of yeah, everybody likes wood, nobody's interested in painting in black. But I think at the end everybody knew exactly why we had to paint it black. Okay, next picture. It's another section. Yeah, they have a little bit of a view about the dimension of the buildings and of these sections. On the left hand side there's the entrance, the elliptical shaped entrance. Then you have a view of the foyer, which contains those huge glasses with nice slim steel profiles. So you have a huge amount of glass. And then on the right hand side or in the center upstairs there are the toilets and technical stuff, and on the right hand side you see the big loading area. Okay, thanks. Next one. There is the entrance of the building. Yeah, I think that's another big quality of Marte architects, because as you can see the real building, it really contains everything which was already set in the first sketches. So in between the sketches and the idea from the building through the building process, they are able to really progress in their uncompromising design. So yeah, it's almost like the first sketch, the building turns out, and that's a high quality. Also with the glass facade in this case, it's yeah, it's very thin and sharp edges, and it allows yeah, sunlight to come in, and there you have a wonderful see-through. Yeah, it was quite an effort during the construction, but in the end, yeah, somehow a big success for me. Yeah. Yeah. I think the pictures speak for themselves.
Perfect, Stefan. Thank you very much.
Thank you.
It was very informative and nice to see just in some of those, both in the drawings and in the photos, just to give an idea of that transparency you get between the rooms, because you are now able to have insulated fire glazing or fire resistant glazing in the steel systems. And that obviously makes a huge impact on the aesthetics of that building. So Stefan, thanks very much for that.
Yeah, thank you. Thank you for having me. Have a good time, everybody.
Thank you. So guys, we're just going to finish off. There've been a couple of questions, and I just want to thank Mariana Carroll, who's been our host. Those of you who saw the splash video when you arrived, she's also got a survey which she's going to put up now, and just 3 simple questions. The old CEO, or possibly the current CEO of Protea Hotels, said to me that don't label your clients. You know, if you go to Audi and you get your service sheet and they phone you and have 100 questions. So we've got 3 questions. He said, keep it simple. Were we hot or not? And would you refer us? So we've got 3 questions that Michelle will put up. If you could answer those, please. And then we've got a couple of, a survey, if you'll answer the survey questions. And then there were a few I just wanted to mention. Kathleen asked a couple of questions. One of them is a little bit higher grade for me. So Kathleen, that one I won't deal with. But just in terms of the current reference projects in the country, we have not yet completed a insulated glazed door, so we're busy with that, and also with working with Kubus at Fire Lab to do the tests on the Class B double door, because that's one of the ones we've had the most inquiries for, and then also typically for the 30-minute insulated doors for tenancy or occupancy separation. I think that we typically what you'd find coming out of a lift lobby then going into an office. So we're going to be looking at And then just another query she had in terms of the cost in comparison to aluminium systems. So the steel systems, it's very dependent on the configurations and how much you articulate the sections. The more heritage sections with more sort of cottage pane and more transoms and sash bars, they're more expensive. But typically it's priced the same as high-end aluminium, like our sister company, or we have an agreement with Schuko, a corporate agreement, and they work with our systems and we work with theirs. So our pricing would be on par with that and other systems, other aluminium systems that are top range systems. So one of the benefits of the steel is that you can do large, slim doors, and one of our largest doors is 6 meters tall by 3 meters wide, a pivot door. And obviously that's just framing, so you end up with an inexpensive product. If you compare it to very cheap aluminium, like the cheapest aluminium you could get in this market, you could probably say as a rule of thumb 2 to 3 times more expensive. And then on the thermal values, just Kathleen, something interesting that I learned actually on the steel. So if I can remember the numbers, aluminium in terms of conductivity is 235 watts per Kelvin meters. Steel is 45 watts, and stainless steel, which was new to me, is not conductive at all. It's 15 watts. So steel actually performs a lot better than aluminium, significantly better in terms of being more of an isolator. And then you asked me a question on the values for the Part XA regs for the modeling, and yeah, on the thermal stuff, maybe I can get back to you on that one, Kathleen. And then Colleen was asking if we're recording. We are recording the session, and as I said, our host Mariana Carroll will make that available to all delegates. The difference in performance on corrosion versus aluminium was a good question from Fritz, and that's a common question for steel. So all of you are aware that ships and industrial pylons and things and oil rigs are all made out of steel. So the paint systems that have been used across the world for many years is one of the 4 ways that our accredited metal workers are protecting the steel. And those paint systems are typically a 2-part epoxy zinc-rich primer, covered then with a polyurethane, a 2-part polyurethane UV stable top coat. And that still gives you a nice clean architectural finish. And then the most common one probably is a zinc-rich powder coating primer with a UV stable top coat, powder coated. And those aren't used that much in this country because of cost, but you get the longevity from those powders. And then there's 2 other ways. One is a thermal zinc spray as a base coat. And then another way of a base coat is to use zinc plating without passivation. And both of those base coats can then be covered with either a wet spray or a dry spray like powder coating. We had a chemical engineer that visited us in the showroom here, and he was able on the west coast in Saldanha to achieve 20 years using the paint systems, and that was offshore. So I think those of you that are engineers and you've worked with steel regularly in the industrial space, you'll have some views, but typically we give advice on those 4 ways of steel protection, and then it's up to the accredited metalworker and their applicator to provide those guarantees to you, depending on the corrosivity category of the project locale. And then was the one more question from Fritz: the difference comparison of weight between aluminium and Jansen systems or the steel systems, and that was a good question. So steel is typically 3 times heavier than aluminium, but because you use less of it because of its higher static values, you could probably work on double that. But as I said to Fritz, because fenestration, the weight of the glass is so much more significant, it's not really an issue. Then I think we've answered all the questions. Yeah. So guys, I want to say thanks very much. We've managed to stick to the time. To our panelists, thanks again for making your time available in stressful times, for joining us in South Africa and helping to introduce these systems. We really appreciate that. And then obviously to the delegates, thank you guys for joining us. It's been great having you, and we look forward to seeing you again.